Alright, let's take a look at this problem again. This is my second time trying interval list intersections. So we are given two lists, first list, second list, which are containing the start and end of the interval. And in my first attempt, I tried to just put values like in array, so that when they are the sum, like I add one for each interval here, and when they add up to 2, I was returning them. I was returning the intervals based on those in the array with value 2. But in those cases where I had like 23 and 24, I was joining these two intervals because I was giving, this was 2, this was also 2, but I couldn't separate them because I lose an information while adding 1 to that specific index. So now we will try something different. I checked some solutions, and in one of them, so I saw a good way to solve this problem. So the first thing that we want to do is, so we have two lists, first list and second list. So we have a result, and while we'll just go over this first list, so we will have I and J 0, right? And I is pointing to the first and J is pointing to the second, or maybe like let's name it as this, so that it's easier to identify it. So if the first is less than length of first list and second is less than length of second list, we continue. And the case, so how to identify the intersection if there's intersection. So we identify intersection if the start of, so if the start of A, okay, let me draw it. So there is intersection if the start of A and end of B, this is like that, and end of A and start of B, we look at them. If this is the case, we have an intersection. So just to make it easier to see, we'll just look at this, the first list first. So I will take the start F, right? So F start, first start and first end, right? And then second start and second end, and we take it from the second list and the second index. And so we check if F start is less than B S end, and B I mean the second start is less than, by the way, they can be also equal, less than the end of first, so first end. In this case, we have intersection, and when we have intersection, we just append to the result. But what do we append? We append the minimum. So to get the intersection here, so we take the minimum of B and a maximum of, like, the minimum of these two and maximum of these two, so that we find this intersection here, right? So the minimum, the maximum of A and B starts, so second start, so maximum of F end and S starts, and also minimum of the first one's end, so first end, and the second one's end. Let me see, minimum of, and I made a mistake there. So here it should be the first start. Yeah, minimum of starts will, no, maximum of the starts. Yeah, maximum of the starts and minimum of the max. So here also it is the same. Also here it is the same, right? Minimum of the starts, maximum of the starts, and minimum of the start of the ends. And if that's not the case, if we don't go in, or if we go in, how do we move to the next one? So here we add this one, let's say, and then we have to continue with this, right? So if, but so the longer one will stay the same. So if the start, whichever one is ending first, so first end is smaller than or equal to let me see, smaller than or equal to second end, then we have to increase the first. So first increase, else second increase, and we return the result. Let's see. Oh, I made a typo there. So, okay. So if this is ending, the first one is ending before the second one, in this case, yes. We just move our pointer to next one. And in the case where, let's say that there's a case where this ends before it, let's say that we have something like this, like don't think about this. In that case, we have to jump to this. And it goes on like that, and we find the intersections using this, like using this if loop, and I mean if condition. We have, if they're onto each other, we understand it with this if statement, and we find the interval using this formula and just append it to the result, and we have our result. And also, if one of them finishes, and then we don't have to continue because we are looking at the intervals, so that that will handle those cases where if one of them is longer than the other one, or if one of them is like empty. So yeah, this is the solution to this problem. And what are the complexities? So let's take a look at them. So time complexity is of, we just go over every length of like them, like whichever is, so n is the length of first list, and the other one is also like that, and then spaces of, do I use any additional space? No, right? Let's see, I'm storing that. No additional space is used here, but we are storing the results, so intervals, where k is equal to num of intervals result. Okay, now I submit it again. So yeah, it's a pretty nice problem to solve, but my first approach was wrong, and this makes really sense. Like this makes sense because you can just identify the intersection by using the values, start and end values, or basically the start I and I of first and second list. So yeah.